Good afternoon, everyone. Now we'll resume our session after the lunch break. Now the speaker is Mr. Bibhudatta Mishra from NIT Rourkela. He is going to deliver a talk on parameter estimation of solar panel. Mr. Bibhudatta Mishra received MTech degree in electrical engineering from Veer Surendra Sai University of Technology, Bula, Odisha in 2016. He is presently pursuing his PhD degree in electrical engineering at National Institute of Technology, Rourkela. His areas of interest include renewable energy systems, power management of hybrid AC and DC microgrid, and inverter control. Over to you, sir.
Thank you so much, Ananya, for the nice introduction. And thank you all the coordinators of this wonderful short-term course for giving me this opportunity to take this lab session. And a very good afternoon and a warm welcome to all the participants. I, Bibhudatta Mishra, present here to take this lab session titled Parameter Estimation of a Solar Panel. So these are the outlines I will cover one by one while taking the session, starting from the introduction and the objective of this session and PV modeling, parameter estimation, simulation result and discussion, and the conclusion part. So coming to the introduction part, let me clarify. I will cover first of all the modeling of the PV panel first of all. Then the second portion includes the estimation of the parameters. While we will take the directly we will take the model from the Simulink library. So as you know, or the photovoltaic modules makes use of the light energy, so the photons from sun to generate electricity through the photovoltaic effects. And the basic operation lies on the principle that when a photon hits a PV cell or of a PV panel, it has enough energy to knock out an electron and allowing it to flow freely. All the PV cells have two layers. One is positively charged and another is negatively charged. Whenever a photon hits that a PV cell, there is a electric field, and that electric field compels one electron to flow and generate electricity. And the PV generally a PV cell or a PV panel behaves as a current source, and with the greater the intensity of the solar irradiance, that is the greater the current on the PV cells. So regarding the modeling part of this PV part, so different regions, it includes different regions like system design and optimization. We can say when if PV modeling helps in designing or optimizing a solar PV system for maximum efficiency and performance by simulating different configurations, orientations, and components, we can determine the most suitable design for the specific location. Similarly, performance predictions. So we should, while designing or while modeling a PV panel, we should consider the different potential or different economic aspects of the PV panel. And regarding the resource assessment, PV modeling crucial for a particular location, analyzing its historical weather data and considering factors like sun angle, shading, atmospheric condition. All these aspects has to be taken into consideration while modeling the PV panel. And regarding the grid integration study, why we should go for grid integration studies? Because PV panel, whenever it is integrated or interface to the grid connection, several grid factors like the grid voltage fluctuations or grid stability, frequency restorations, all these aspects should be taken into account while designing a PV cell or PV channel. And the last, not the least, that is the technology development. So nowadays, different new technologies are introduced, or many researchers have introduced to most efficient technologies to design a PV cell so that it can have the maximum efficiency along with optimal operation. So what I mentioned in this lab session, I will go for these 4 objectives to be completed. one by one. First of all, being the simulation of a solar panel at various level of insolation, temperature, plotting the IV and PV characteristics. And the second one being we draw various characteristics by varying the load resistance. And the third one to find out the impedances, that is dV by di at V equal to open circuit conditions, and dV by di, the impedance value, two impedance values we need to determine at open circuit condition as well as the short circuit conditions. I will discuss in details in later on slides. And the last one, to estimate the parameter of the PV panel from the PV characteristics. PV characteristics. So coming to the PV modeling part, so there are two well-known methods for two well-known widely used models. First one being the single diode or the single exponential model, and two diode or double exponential models. In single diode model can have also two different categories. That is, one is a 4-parameter based model, another is 5-parameter based model. In 4-parameter based model, we don't take account of the shunt resistances, and in a 5-parameter model we go for considering that shunt resistances. So basically, comparison to that 4-parameter models, we prefer for the 5-parameter modeling. And figure 1a shows the equivalent circuit of a single diode model, and figure 1b shows the equivalent circuit of a double diode model. So for PV modeling part, if I appreciate all of you, if you can have the accessibility of MATLAB of any version more than above 2016 version, simultaneously we can go for modeling the same one by one, step by step, making use of all these equations. If that will be helpful for all of you, while I will also do alongside, we all can proceed on same way. So first equation for equations for IPV, that is IPV nominal plus Ki delta T, that is T minus Tn, and G by Gn. All the parameters has already been mentioned. So I will first of all I will proceed for modeling a PV cell, and I appreciate all of you to do the same alongside me. So while modeling, if anyone finds any kind of doubt, can also raise or ask while I am doing the same, so that this session will be much more interesting and meaningful also. So in the Simulink platform, going to a new tab, new Simulink blank model file. So first of all, we need to declare the variable, that is temperature, standard temperature as well as the irradiance. For that, so one constant I am taking for temperature, which the standard temperature being 225 degrees centigrade. So in Kelvin it will be 273.15. So this I am assigning it, making it up on go to block, so that I can rename it as temperature and the variable name being T. In a similar way, for irradiance, as you know, the standard irradiance value being 1000 watt per meter square. I am assigning this value to 1000. And the variable name being capital G. So basically, For PV modeling, we'll follow all these equations. We'll model as per these equations only. First of all, I'm assigning or declaring the values of Gn and Tn. That is the standard irradiance and the standard temperature, 25 degree and 1000 watt per meter square. Then second case, modeling for IPH, photon current, or IPV. Modeling for IPV or IPH. So here IPH equal to IPHN. IPH equal to IPHN, and the IPHN value means nominal value of IPHN. Already we have taken those values. IPHN 8.214. So a constant block assigning the value 8.214, and we can, for our convenience, we can also rename this. This is a IPHN. Similar way, this is the temperature simply. Temperature, and this is our irradiance. Okay, then formula says IPHN or IPVN plus KI, and the value for KI, it is 0.0032. Referring to the parameter values, we can model the same. So IPHN, so KI into, this is KI, and the value is 0.0032. 0.0032 Ki into delta T. Delta T means T minus Tn. So already T is any value we can change, as on the objective part I have mentioned for different values of temperature and different values of irradiance. We can have the modeling, or we can have the PV or IV curve. That's why this declaration can be changed depending upon our requirements of temperature value or the irradiance value. And Tn being fixed, as Tn is fixed, we can make the Tn value constant, that is 273.15 plus 25 degree. 25 degree converted to Kelvin, that is Tn, T minus Tn. So this is the T, and this is the T minus Tn. For this, we are making one sum or add block. T minus Tn, that is multiplied with Ki, means one product. So this term is completed. Ki into T minus Tn, that should be added with IPHN or IPVN.
Hybrid mode.
Yes.
Video record அனுப்புவீங்களா சார்? ரெக்கார்ட் யூடியூப் போடுறேன். யூடியூப்ல
Any queries? So T minus Tn IPS it should be multiplied with G minus Gn. Similar way, Gn is fixed. We are taking 1000 watt per meter square Gn, and G is on from block we can use so now G divided by Gn, can mention this is capital Gn. G divided by Gn to be multiplied with the term IPHN plus Ki delta T. This is the IPHN plus T minus Tn, that is T minus Tn T minus Tn, which models the IPS. So this is IPS. Now the modeling part of modeling for IPS is over, and for further use of this T minus Tn, we can denote it as, for our convenience, we can make use of one go to block. Directly we can use, that is dt, difference of the nominal value of temperature and the temperature we need to access for. Then second part, modeling of I naught. So I am moving towards that slide where I naught formula for I naught is there. That is I naught equal to ISCN plus Ki delta T. Directly I am taking T minus Tn as delta T, exponential function of VOCN Kv del T minus delta T by AVT minus 1. And what is all the variables or the parameters used, that has been mentioned in the slide, and the values for the constant term was also given in the slide, taken from a standard paper to model the same. So for I naught, modeling of I naught, we will make use of ISCN. What is the value of ISCN? Short circuit current, nominal short circuit current, it is 8.21. Similarly, VOCN 32.9, and KV, that is minus 0.1230, KI 0.0032. So we'll make use of all these values of the parameters to model that I naught. So moving. So I'm taking one constant for M for IOCN, for VOCN, that is 32.9. The formula says I'm going for denominator part first, that is VOCN plus KV delta T by AVT. VOCN, that should be added with KV delta T. KV is also one constant having value of KV being minus 0.123. So KV into delta T. Directly I can take one from block here, that is dt. These notations, yes, dt into KV, dt into KV, dt into KV added with